Hello, welcome to this video. Am I audible now? Hello, welcome to this video. My name is Odio Craig. I'm here with my group members. We are working on a project, medical sign language to text and audio AI system. So these are the keywords that the system majorly deals in. It's a large vision model, Uganda sign language, infectious disease screening, and graph-based reasoning. And then real-time sign language translation and inclusive healthcare. Below are my group members, the one I showed you just a few seconds ago. Mogara Albert, Maniragaba Brian, and those are their names and their details. So these are the contents we are going to be presenting today about the project that we are building. So we'll do the introduction and the related work that has been done close to our project, and the problem statement, research questions and objectives, research contributions, methodology or system architecture, and data description, results or experimental or simulation, conclusions, anticipated limitations, and interaction plan, and then references and acknowledgement. So starting with the background and introduction, when we started the idea of this system, we realized that deaf patients, they have trouble telling doctors their symptoms when they go to the hospital. So diseases like malaria, tuberculosis, cholera, they normally need clear text. So there should be a mean by which the deaf people, they communicate to the doctor so that that problem is taken care of. So the system works both ways. The patient signs to the doctor in Uganda Sign Language signs, and then the system converts to text and avatar in Uganda Sign Language. And then the doctor do the same. They give the questions they want to ask the patient in text, or maybe they can speak it out, and then the system will convert it to avatar in Uganda Sign Language system. The system will be so focused on Uganda Sign Language majorly, since we are going to start from Uganda, and then maybe we can expand. And then the goal is to fix the talking gap, the top gap in health care. And then when you go to related works, recent trends, and then literature review, works that have been done close to our system. In 2014, they produced a data set called RWTH Phoenix Weather 2014 dataset. That is majorly focused on weather or news, but it's not health related. It's not so focused on the health sector. And then they've also built virtual signing avatars used mostly in schools, but not for doctors. So the gap we want to fill here is that few systems in Uganda, they use Uganda Sign Language, and then also used in the health sector. So that's the gap we want to fill with our system. Yeah, so the main problems, or the main problem for this system is to handle the talk barriers between the patients and doctors. And then the computational problem is what we are trying to build an AI that supports Uganda Sign Language health science from video, and then outputs text and audio so that the doctors can understand, and then they take note of the patient's conditions. And then the same applies to if the doctor is trying to communicate to the patient, the system turns the doctor questions into Uganda Sign Language avatar so that the doctor can understand what the patient is trying to say. And then the research questions and objectives. Here are the research questions. How to change the dataset we have got for health Uganda Sign Language, and then which AI models best for in the sign sequences, and then how to make it strong and clear in health settings. And then the objective is to design a system for sign to text or audio in health sector, and then to filter datasets for health words only, and then to train. These are the models we have chosen to train the vision transformer, which is short from SVID, and then that model for the system. And then another objective is to add an avatar for both way talk between the doctor and the patient. So I'm going to give the next part to my group member to continue from my abstract.
My colleague stopped from the research questions and objectives. I'm going to resume from there. My name is Mugara Albert. Yeah. So I'm going to start from the research contributions and outputs. One of them is like to make a plan. What are the research contributions and the outputs that we shall come up with? Is to make a plan for health sign translation. We built dataset with focus on disease checks. We have around 463 clips, and then we've used a model of VIT and GAT for video spot checks, made a line for doctor-patient talk both ways, and then added rules for safety and privacy so that no one else can access or use the information the way they want. So we've come up with the rules for safety and privacy. So now we have the methodology of the system architecture, how step by step. It starts with the Uganda Sign Language video input, then you go to the pause extraction, which is where the deaf person is communicating. Then our model will come in to translate those languages to text, audio, or to the avatar. This is the architecture of our system. Later we've gone to the dataset description here, trying to describe the dataset. Yeah, originally it's an 80 video hours, and now to 463 healthy focused clips. So, and the data types will be videos, to be texting, and then audio as well. Then the processing, we have the frames and adjusted the sizes so that it's very clear. We've added a 2D pose points for hands and body. Then balanced classes very well with duplicate samples. Now the EDA, that's the explanatory data analysis here, will be showing the number of words and the frequency. Number of words and the frequency is the number of times that it has appeared. They have appeared. Then down here there are total unique videos. Yeah. So briefly that's how the sentence length distribution is. Yeah. Then from our data set, this is how our columns are to be. There are 7 of them. We have the video ID, the video name, sentence ID, sentence name, aligned, the start realigned, the end realigned, and the sentence. Then here they're also showing you the data type. Yeah. So in the next slide, as you can see here, this is how they explain how they're going to look like in the table. Yeah, and how in their columns, beginning with the video ID, video name. This is an image got from our datasets, our dataset that we used. So now, what are the expected results? Here, you can see that in our columns we had zeros, showing that we don't have any missing. Like nothing was missing. That's why it is bringing the zeros. Yeah. Even the data type there, variation, and here the results of this thing is that the model we trained. It starts with inputting the signs, then the model prediction. This is where that translates these things. Then Bayesian confidence comes in when when it interprets the signs, when someone communicates, and then this one interprets. So it gives a percentage on how it has understood. If the percentage is high, then it gives the output. But if it is low, it just doesn't give anything. So here, this is the medical related entries. This is how I think it's a healthy department. That's why it's the same like the other one from the data set that shows the columns. The headers, they are the same, but this one is the one for the medical entries, still with the 463 clips. So this is how it looks like.
So for me, I'm continuing from where my colleague stopped. So my colleague stopped from here. Now, these are the from our project. These are the medical related entries. Where we have the video ID, video name, sentence ID, sentence name, status aligned, and the end aligned sentence and sentence length, which has the results and the discussion for the output. This is how it looks like. For the model selection, for this part, model selection and architecture, we have chosen the model to use, which is the vision transformer plus the graph attention network model. And we have chosen the reasons why we have used this model. For example, the VIT model. It's because it is good at seeing and understanding the video frames. That is, it breaks videos into small parts and runs patterns in perfect for spotting Uganda sign language frame by frame. For the case of GAT model, it's great at connecting pause points, for example, hands and body moves. That is, it focuses on important parts of sign sequences, for example, complex gestures. For the architecture of the model, for the case of vision transformer, we have to input where there is video frames. For example, 224 by 224 pixels, which is split into 16 by 16 punches. The layers, where we have 12 transformers layers to process patterns. We have even the heads that is 12 attention heads to focus on different parts. The output, where you have the feature map that is 768 dimensions for sign details. For the case of GAT, input, it takes 2D pose points, e.g. 17 key points from tools like media pipe, which is used to mark where hands, elbows or shoulders move in the video. For the case of layers, it uses two graph layers to connect these points, like drawing lines between moves to use the full sign. For the case of heads, with 8 attention heads, it picks the most important connections, focusing on the key gestures that define medical signs. And for the output, it produces a graph embedding the 256 dimensions, where there is a complete summary of the sign sequence that helps to verify it. For the next slide, we are looking at the conclusions and limitations. Conclusions, we have tried to make this bridge medical communication gap for the deaf patients. This project will use AI plus sign language for real world healthcare impact. For the case of limitation, which may limit our AI, we have data set not fully medical. Another limitation, we have the class imbalance. Another one, we have the aviator generation still under development. Next steps we are to look on, we have to build a larger medical focused dataset for Uganda Sign Language. We also deploy prototype in healthcare settings. We can also improve avatar realism and responsiveness. and also explore transformer-based models for better accuracy. For acknowledgements, the supervisor was a lecturer who was Kangaroo Marvin, where you can find him at Coast Mackay University. For collaborations and volunteers who contribute to data collection.